In this session, I'm going to cover everything you need to get started with statistics. In day-to-day life, we come across a lot of information in the form of numerical figures, tables, graphs, and etc. These are provided by different types of communications like televisions, newspaper, radio, and magazines. We all know we withstood COVID-19, right? So how is the data of COVID-19 being categorized into? Be it like the number of cases rising up every day from different countries, number of recoveries, and finally the number of deaths. All these numerical or others collected for a specific purpose is called the data, which is then processed to represent it in statistical form. Now, let's discuss the concepts of primary and secondary data. Suppose I want to understand the number of people who are more than 150 centimeter tall and between 120 and 150 centimeter in a population. How do I approach this problem? I need to measure the heights of each person in the crowd and tabulate the same. Here, the heights of the people are the raw data or the primary data. If a researcher makes use of this data that I've prepared, then the data becomes secondary data for him. So what exactly is primary data? Primary data is basically the information collected by the investigator himself or herself. What is secondary data? Secondary data is gathered from a source where data is already being stored. Suppose you need to analyze how many types of vegetables are there in this basket and you need them to sell in a vegetable shop. What would you do? The first and foremost step of analyzing statistics is to collect the data. So here I have collected some fresh farm vegetables and I need to categorize them to tomatoes, carrots, cucumbers, and so on. And I need to have a count of each one of them too. The data in this form is called raw data. Having collected the data, now I need to present them in a manner where I can pick any vegetable easily. So here I've got a count of all the vegetables in the basket and have named them specifically with their respective counts like 10 carrots, 5 onions, 6 cucumbers, and so on. This implies that I've presented my data neatly. Let's consider another example. There are 5 students who have scored marks in English in an annual exam out of 100, and their scores are 78, 90, 82, 65, and 88 respectively. So this is an example of primary and raw data. What if we want to know the difference between the highest scoring and the lowest scoring student? The next step is that you arrange them in ascending order. It's quite easier to arrange when there is a small amount of data. From the data, we see that 65 is the minimum score out of 5 students and 90 is the maximum score in the data. Finding the difference between them, you get 90 minus 65, which gives you 25. The difference between the maximum and minimum scores is called the range of the data. Here, 25 is the range of the data. Suppose you're given marks of 21 students and you need to count the number of students who scored exactly 29 marks. What can you do? Finding the number of people is going to be a difficult task from a set of random numbers. Here, what we can do is that arrange the data properly so that our work is simplified. Arranging a large amount of data is a tedious task and time-consuming. So what we do here is that we count the number of observations occurred and group them accordingly. From the data, we notice that 29 has occurred twice, 38 twice, and so on. The number of times the observations occurred is called the frequency of the data. To make the data more understandable, we write the data as shown in the table and finally totaling the number of students to 21. This is called ungrouped frequency distribution table or simply frequency distribution table. So what is grouped frequency table? Grouped frequency table is nothing but data which is formed by aggregating individual observations of a variable into groups, which is discussed in future grades. Here, we concentrate on ungrouped frequency distribution table. Now, what if you get the marks of 200 students? How do you arrange the same? Well, in this case, we make use of frequency distribution table. Let's consider the weights of 30 scholars in a class. So there are two columns here, one with weights in kilograms unit and the other one is the number of scholars belonging to the respective range of weights. Think of a situation where you want to admit two new students to the class of weights 40.5 kilogram and 45.5 kilogram. We cannot add them in the ones ending with 40 and 50. This is because there exists a gap between the upper limit and lower limit of two consecutive classes. Therefore, now we consider the classes 35 to 40 and 41 to 45. Take the upper limit of the first class and lower limit of the second class. Upper limit of the first class 35 to 40 is 40 and lower limit of second class is 41 to 45 is 41. Calculate the difference between them. That is 41 minus 40 gives you 1. Right. Now you halve the difference of that which you're getting as 0.5. Now we subtract and add to each of the range of class interval to obtain a new class interval. That is 35 minus 0.5 to 40 plus 0.5 we obtain 34.5 to 40.5. Similarly, we subtract to the second range of the class interval to obtain a new class interval. That is 41 minus 0.5 to 45 plus 0.5 we obtain 40.5 to 45.5. The same applies to the other range of class as well. So the newly introduced frequency distribution table looks like this. Now the question is, where do we add 40.5 and 45.5? Because it occurs in both the class intervals. While allocating frequencies to each of the class interval, students falling in any upper class limit would be considered in the next class. That is 40.5 is added to the range 40.5 to 45.5 and 45.5 is added to the range 45.5 to 50.5. Therefore, we understand that the given raw data is being classified into primary data and secondary data. Primary is the data collected by an individual directly, whereas secondary is the data being used which has already been prepared.